What's going on, guys? So I'm coming to you today here. What we're going to be doing today is I'm going to walk you through how to hook up a PID controller. These things are really handy, especially for controlling like a temperature on either a heat treat oven, for tempering blades, or like cook pot for brewing and things of that nature, where you want a consistent temperature for a certain amount of time, where you don't have to keep having to mess with the controls and adjust it. What the PID does is it actually reads the temperature off of a temperature probe inside of the unit, sends that information back to the controller, and the controller in turn turns whatever heating element that you have attached to it on and off, and it'll run it for a certain period of time and then see how much the temperature increases. It's actually a pretty smart device. What we'll do today is I've got everything already basically crimped up. All my connectors and stuff are set and ready. I'm gonna get the camera over here where you can actually see down in here. I just got a regular old electrical box here that I've cut my openings in, and once we get into it, you'll see how it all just flows and fits together. All right, guys, I got you over here. So I will put links to every one of these pieces down in the description below this video. First thing we got here is our little box. This is basically an electrical box. Picked this up off of Amazon, like I said. Not that expensive. I think, you know, it was cheaper than an electronics enclosure. And it was actually easy to work with and easy to use. I didn't have to really cut hardly anything out of here. Really, the only thing I had to do was rip one tab out, and you can see that down here. I broke that tab off there. Outside of that, everything that we've got fits in this box and actually sets up and does great. First thing we're going to do is we're going to start getting stuff mounted in here, and we're going to do the heat sink for our solid state relay. I've got a washer on this nut down here. I don't know how well you'll be able to see it, but it's down here underneath the nut, and what I want to do is make sure that that washer falls down against the nut so I can put this in. Now, I can't see what I'm doing, but that's basically the concept there. Now, looking down in there, it looks like the washer is on top. Now I've got another one, little screw nut and washer here. We're going to put that in. We've got our screw in, drop our washer on, and these actually fit pretty snug, so you don't have to hold the nut. It actually holds against the heat sink, and what I'm going to do is just tighten it down, get it snugged into place, make sure it's not going to come loose. We'll do the same thing with the upper one. We got that tightened in. Now, if you look down in there, and I'm not 100% sure how well you can actually see that, down there is that nut. There's no way I could get my fingers down there to hold that. Luckily, this thing is notched on the edge there to where you can just slide it in. So that worked out really good. Next thing we're going to do is we're going to set our solid state relay. Now, in order to do that, we need some, I guess what you'd consider heat grease. Same thing you'd use on like a computer or any type of electronic device where you want good heat transfer. And I am about out here, but I think we're going to have enough basically to smear some on here. And we should get a good transfer. Kind of got it caked up there in the middle. Make sure we get all of it out. There we go. Right, so this stuff is thick. The kit does not come with this, and that's something I have to emphasize. You don't get this with the kit. You have to buy it separate. I'll have a link to it down in the description. We're going to set this on there, and we're just going to move it around and twist it back and forth so we get that stuff smeared out. It's almost like putting a processor onto a motherboard. You won't, well, excuse me, you put the processor on the motherboard, and then you put the heat sink on the back of it. And that thermal paste is what transfers the heat out of it. So we'll put our 2 screws in. I get both of them started and then tighten them up. Oops. That one, here's that one. All right, so that has got our solid state relay and our heat sink mounted into our panel. So now what we need to do is we need to run our electrical wires in. And you'll see down here I've got 2 holes here. The lower one is for our incoming power supply, and this upper one is going to be for our aircraft connector that does our temperature sensor. So we'll feed these wires in. Now, I want you to understand, I've already cut, stripped, and crimped, and soldered all these connections. I did that prior to setting up for this video, just because I didn't want you to sit here and have to watch me crimp one wire at a time. So I did that to speed the process up for this. It's going to make the assembly a whole lot easier. Hopefully, I can get this screwed in here. I had it in here once already. For some reason now it's not just wanting to cooperate. There we go. Tightened up. I'm going to back the jam nut off just a little bit there for the cable. And these are gland connectors. You can get these at Lowe's, Home Depot, Amazon, anywhere. You can use plastic ones or you can use metal ones. I'm using a metal one on here because it's just what I had on hand to build this with. And we're going to tighten this down until it goes all the way in. And once it's seated into the plastic, you can see there it's down and it's flush. And we've got a nut to go onto the back of it. We'll just feed our wires through it, send it down. And then spin it on there. Now, this thing's screwed into the plastic. It would probably hold itself there, but we're going to put the nut on it just for a safety measure because this is a 220 circuit. 220 volts will be running through this. We definitely don't want it to pull loose. We just want to do it right, do everything nice and secure. Now, that's tightened down. We're going to feed our SOW cable up in there, and this is 12-3. It's got 2 12-gauge hot leads in it, the white and the black, and then it's got a green ground. And that's all we need for this. That's all we need for this 220 circuit. The receptacle here has 2 hots and a ground, and that's what we're going to connect to, and that's how we'll set this system up. And 12 gauge is enough for 20 amps, and that'll handle up to roughly 3,500 watts of heating power on amp draw. So you should be good to go there without any trouble. All right, so we've got that put in. We're going to tighten our gland nut down just to hold our cable in place. That'll help us out on our assembly here. There's that. Now, next thing we're going to do is we're going to set up our socket. Now, I know this looks like a household socket, but if you'll notice, it's got the little slot off to the side there. That tells us that it's a 20 amp socket. And then I bought this as a 240 volt, which it says 250 volt here on the receptacle. It's got 2 gold terminals instead of a gold and a silver. That's the important aspect here, is to make sure that we have a socket that's rated for the voltage and amperage that we're going to be using. So we're going to run this ground wire around through here. And again, like I said, I've already crimped connectors on here. That way I don't have to bore you with that. But I'm going to get these tightened up, and I'm going to make sure each one of these is nice and snug. Now, you know, normally on a receptacle, you can just put the wire around the screw and tighten it down. But since this SOW cord is a stranded wire, I didn't want to try to wrap the strands around this and tighten it down and not get a good connection. I wanted to use the actual crimp-on connectors and solder those in place and then heat shrink them to seal them so we don't have to worry about it coming loose at any point. So the next one we're going to do is going to be this hot lead down here on the bottom. We'll get it attached. And for those of you that are wanting to know, yes, I'm going to have a wiring diagram, and I will put that up at the end of the video where you can basically stop and take a screenshot of it and print it off. I'll have it drawn out on the whiteboard and add that at the end of the video for you. All right, so that's got us set up there. Everything's connected. Now, we're just going to tuck this stuff in nice and neat. And we should be able to go ahead and put the screws in the receptacle. Now these I just have threaded into the box. Should hold just fine. We're going to screw those in now. Guys, if you don't have one of these Southwire ratchet screwdrivers, I highly recommend it. Switch out tips and everything in it. Phillips flathead, nut driver. You can flip it around. It's got more bits on the other side as well as different size nut drivers. I think it's like 11 in 1 or something like that, but plenty of tools in one compartment there. One tool does it all. If you're doing electrical work, it's got all the common sizes and stuff that you're going to need to do electrical work, and it is an awesome piece of equipment to be using. I'll put a link to it down in the description for you. All right. Tighten our receptacle into place. There we go. All right, so there's that. Now, the way this system works, and you'll have to look at the wiring diagram once I put it up at the end so you see where all these leads are coming from. But what's going to happen is now this second hot lead, in order for us to have voltage on this receptacle, we've got to have a connection on both sides. So what we're doing now is we're running the output, or excuse me, the 240 volt input of our relay is coming in right here. So that's going to be attached. So now we have power coming into our relay. From that point, we need power coming out of our relay, going to our receptacle. But keep in mind, there's never going to be power there unless the unit is turned on and the PID controller tells this relay to close. So it's not a matter of that, you know, as soon as you plug it in, you're going to have power on the receptacle. You'll have to program it for the parameters that you want in order for it to connect and actually send power down to the receptacle itself. Get this put on here. There we go. Now we'll tighten it down. And like I said, guys, each one of these terminals has been crimped on and then soldered. That way we know that they are stable, they're not going anywhere, we're not going to have a problem with them. Next thing up, we're going to pop our aircraft connector in. This is going to be for our temperature sensor. When we install the temperature probe, basically a thermocouple, it's going to send the signal to the PID controller to tell it what temperature it is, and that's going to in turn tell us how hot things are, how cold things are, whatever the case may be. You know, I talked about using this for brewing. A lot of people set these things up and use them as like a work chiller, and they'll set a temperature for it, and they'll utilize that aspect in order to maintain a temperature in a work. That way they can continue with their brewing. A couple of different tools here. Let's get this tightened up. You hold on to it on the outside. And we'll snug this down here. Guys, you got to keep in mind too, you're putting this stuff in plastic, so you're not going to be able to tighten it down with like an impact gun or something to that extent. You just basically want it snug enough that it's going to hold it in place and it's not going to fall out. So there's our temperature sensor. It's loose. Now, what we're going to do is we're going to connect our plug. All right, so we switched out batteries there. And if any of you were paying attention, you probably caught my mistake. But I actually did make a mistake. I had this wire set up on the output side of the relay to go to the switch, which was a mistake on my part. I was trying to build this without actually assembling it, and then once I started assembling it, I realized I had it on the wrong side. So what we're gonna do is we'll take this hot lead loose right here. And we're gonna add this second wire onto there. There we go. Now, what that's going to do is that's going to send the power from our 240 volt circuit, which is 120 on this side and 120 here coming in from our outside line. This is our main line coming in. And then we're going to send 120 to one side and 120 to the other side, and that's going to give us 240 total. But because we're only controlling the actual PID with this switch, we don't have to use 12 gauge wire. We're only drawing like half an amp. Actually, I think it's 0.05 of an amp. So it's not very much power. The wiring diagram is correct. I just didn't catch it when I put it together. So that was my error. But luckily we caught it here while we're putting it together. Now, we've got our switch in place. We've got our power connected coming into it. Just like that. Nice and neat. The next step is that we're going to be able to actually put our PID controller in here. Now, there is two terminal outputs here. One, this one goes to the relay itself and controls the relay. This one goes to our switch, which turns the unit on and off. And then down here, we'll have two connectors that are going to go to our temperature probe to tell the unit what the temperature is. So we're going to start sliding this in. We'll feed our wires in, just like that. Now, I'm not going to push this all the way in because it's going to be really hard to attach down here. So what I'm going to do is slide this back out now, feed this in, and take our two terminals loose down here. And I know that this lower one here is positive and this one is negative. Now, you know, the thing of it being is if you hook your temperature probe up backwards, it's going to read backwards. So we want to make sure we have it correct. And I have numbers on the back of this aircraft connector, 1 and 2. 1 is positive, 2 is ground. So when I hook up the actual thermocouple, I know that the positive side of the thermocouple goes to 1 and the negative side of the thermocouple goes to 2. So now we're going to get this screwed onto here. There's our negative side connected. We'll get our positive side connected. Now we'll use our screwdriver to tighten these down. And again, guys, these are going into, well, these are going into metal, but it's still, I mean, this is a plastic housing. I'm gonna double check my connections over here to make sure they're all tight, because I did build this out. See, that one's loose. There we go. All right, now we've got our wires and stuff connected to our PID controller. Fold these in. We'll put this down and this one, and we'll slide this PID controller in here. Just like that. Now, the first off the bat thing that I see is I've already made another mistake, and I forgot to put my lock bracket on the back. So, hey guys, it happens. You know, I'm human. I make mistakes, and this is the first one of these I've built, so it's kind of a learning experience for me, and I'm sharing the information with you as I go along, because here it is. I've never built one of these before, and now you're following along as I'm building it to see how it's done. And, well, I mean, we're going to learn together, I guess. So let me feed this through here. There, now. I'll drop both of the screws inside of the box. Now we've got that in there. We can come back and reattach this. And again, we know our positive is on the lower side, so we're going to the ground to the upper terminal. Now there's other terminals on this to where you can hook up an alarm. You can do different types of sensors. You know, we'll utilize the 2-wire sensor to read temperature. There's other sensors that you can buy for these to do different things as far as liquid temperatures, 3-wire control, different temperature ranges, whether you want it hot or cold. So now we feed all our wires through our lock. Make sure we put it in right side up. All right. Now, so what we'll do, push that straight in, and it locks in. Now there's 2 Phillips screws in here that we're going to tighten down, and that's going to snug it up. There's that one. That one down there is going to be a little hard to get to, so there we go. All right, so we got that in. We're going to move this, which is our relay control, slide it down. I'm going to get it ready to install. And this thing is marked positive and negative, and I'm on the positive and negative terminals coming off of the PID controller. I don't know if you can see it in the camera, but I actually marked this when I was in the process of setting everything up with a pencil, just so I could remember it without having to reference back to the wiring diagram. And this does come with a wiring diagram, guys. You can get, you know, the complete instruction manual and the wiring diagram. Everything is there. It's not that difficult. You know, I know it looks complex. Theoretically, you don't have to put the switch in it. You could just plug it and unplug it, but I kind of wanted the ability to turn it on and off when it was plugged in, just as an added feature. So we've got that connected. Now the last thing we've got to do is connect our 2 leads to our switch, like that, and like that. Now, my cover plate was a little bit big. I have to look and see if they make a smaller one, but I actually just trimmed the edge of it here where it would fit right on. There again, that screwdriver, flip that bit around and we'll spin this right in. All right, there it is, guys. PID controller, built in a box. Grab the lid over here, snap it on. I'll just get 2 of these tightened up for right now so you can see the whole thing finished. There we go. There it is. That is our PID controller. Now, one of the things that we may want to add would be some cooling. Put a cooling fan back here and use a 240 to 12 volt transformer. Just use like a little computer fan here to blow air across that heat sink. We probably won't have to do that. We're not going to be running this thing that hard and continuous. It shouldn't have a problem dissipating the heat. Our aircraft connector down here, 2-wire. If you're going to use a 3-wire probe, then you're going to need a 3-pin aircraft connector. And I'll put links to the 2-pin and the 3-pin down in the description. We got our cable locked in. We got our spool of cable here. Now we can pull out and make our cord to where this will plug into the wall and give us our 220 volts coming in. Our PID controller will come on. We'll be able to set all of our settings in it, and we'll be able to plug a 240 20 amp plug into this receptacle and go out to whatever device that we're going to use it with, whether it be a immersion chiller, a heater, whatever the case may be. We're going to have the ability to do this and set this up to where we can control the temperature. We basically set our set point, tells us what we're reading. It'll read in Fahrenheit or Celsius. It gives you the ability to set an alarm. There's a multitude of functions in this Inkbird controller, guys. It's just a matter of putting the components together and setting it up. And you saw there, it only took just about 20 minutes or so for us to actually put this one together. All right, guys, so there it is, PID controller. Listen, I appreciate y'all tuning in. I hope this video helps you out. Again, these are for entertainment only. You do this at your own risk. I accept no liability. I'm no master electrician, nothing like that. I'm just putting this video out there for entertainment. Be sure, hit that subscribe button. Give us a thumbs up. Drop comments or questions down below. Remember, I'll put the links to all this stuff down below that you can go and purchase it off of Amazon. And stick with us, guys. We're going to be coming to you with more videos.